Welcome to the Cypress College Math Review on factoring with negative and fractional exponents. In this video, we're going to review techniques for factoring with negative exponents, factoring with fractional exponents, factoring with binomial bases, and factoring with fractional coefficients. In all cases, your final answers must be written in simplest form with positive exponents. So we'll begin with factoring of negative exponents, and just like with positive exponents, you have to factor out the variable whose exponent is the smallest. If you look at this quick example, negative 5 is less than negative 2, so we would factor out an x to the negative fifth from this expression. Okay, let's take a look at example 1. We have to factor out the greatest common factor. We're going to be taking out a negative 5, x to the negative 10. Now what we have left, you can think of it as division. If I take negative 5 and divide by negative 5, I'm left with 1, so our coefficient will be 1. If I take x to the negative 6 and divide it by x to the negative 10, what I really have to do is subtract negative 6 minus negative 10, and that would become x to the fourth. Now, because we have a plus sign in front of the 30, but we factored out a negative, that means we're going to need a minus sign in here. 30 divided by negative 5 is negative 6. X to the negative 10th divided by x to the negative 10th is 1, so there's no x variable there. Now we need to have all positive exponents in our final answer. So we'll need to move that x to the negative 10th into the denominator to make it x to the positive 10th. The negative 5 stays in the numerator, and the x to the fourth minus 6th also stays in the numerator. And there's our final answer. Now in example 2, we can see that our greatest common factor is going to be 8x to the negative 7th. So then we can see 8x to the negative 7th is what we pulled out, so we're going to need a 1 here, minus 3x squared. And again, the x squared is because when we do x to the negative fifth divided by x to the negative 7th, we're really doing x to the negative 5 plus 7, which is 2. Now all that's left to do is get that negative exponent into the denominator. So we have 8 times 1 minus 3x squared in the numerator and x to the 7th in the denominator. And there's our final answer. In example 3, we have fractional exponents for the first time. Now when you're factoring with fractional exponents, you do exactly the same thing you always do, which is to factor out the lesser, meaning smaller, exponent. If we look at this quick example here, we have x to the 3/2 plus x to the 1/2, and since 1/2 is less than 3/2, we would factor out x to the 1/2 power. Now let's go back to example 3. So we first have to take out our GCF, which we can see between 4 and 6. The coefficient we can pull out as a 2. Between x to the 5/3 and x to the 2/3, the smaller exponent is 2/3, so that's what we can factor out is x to the 2/3. And then what we'll have left doing the division here, 4 divided by 2 is 2. X to the 5/3 divided by x to the 2/3 is x to the 3/3, which is x to the 1. Then we have our minus sign there. 6 divided by 2 is 3, and x to the 2/3 is what we factored out. And there we have it. 2 times x to the 2/3 times the quantity 2x minus 3. In example 4, the greatest common factor between 32 and 20 is 4. Both of them are negative, so the coefficient that we'll factor out is a negative 4. Looking at our variables, we have x to the 5/2 and x to the negative 1/2. Clearly, negative 1/2 is the smaller exponent, so we'll factor out an x to the negative 1/2. Alright, now what we have left, negative 32 divided by negative 4 is positive 8. X to the 5/2 divided by x to the negative 1/2 means we have to subtract 5/2 minus negative 1/2, which means we're adding 5/2 plus 1/2, which would be 6/2, which is x to the 3rd. Now here we have a minus 20 divided by a minus 4, so that's going to be a plus 5. And x to the negative 1/2 divided by x to the negative 1/2 is 1. The only thing left to do is get that negative exponent into the denominator. So the negative 4 stays in the numerator. The x to the negative 1/2 moves to the denominator and becomes x to the positive 1/2. And then the quantity 8x cubed plus 5 stays in the numerator. And there's our solution. Now, starting with example 5, we start working with expressions where the bases of the exponents are binomials rather than just single variables. But all the techniques are still the same. The first order of business is to find the greatest common factor. And you can see between 14 and 7, our coefficient will be 7. That's what they have in common. For the x variables, we have x cubed and x squared, so the greatest common factor will be x squared. And for the x minus 3 factor, negative 7 is less than negative 5, so we'll be able to factor out an x minus 3 to the negative 7. So our greatest common factor is going to be 7x squared times x minus 3 to the negative 7th. As always now, we do the division to find out what's left inside. Let's look at this in two pieces. If we have 14x to the 3rd divided by 7x squared, that's going to be 2x. And if we have x minus 3 to the negative 7 divided by x minus 3 to the negative 7, that would be 1. So 2x times 1 is 2x. All right, then we have a plus sign. Now we have 7x squared divided by 7x squared, so those will cancel out. We'll have a 1. Here we have x minus 3 to the negative 5th divided by x minus 3 to the negative 7th, which means in terms of the exponents, we'll have to do negative 5 minus negative 7, which turns into negative 5 plus 7, and so we get an x minus 3 squared. So now let's simplify. We know 7 will stay in the numerator. X squared will stay in the numerator. The x minus 3 to the negative 7th will head to the denominator and become x minus 3 to the positive 7th. Inside the brackets here, we have 2x plus. Now we need to use a special product, and we know this will be x squared minus 6x plus 9. Next, we can combine like terms, and we now have 7x squared times x squared minus 4x plus 9 inside the brackets, and in the denominator we have x minus 3 to the 7th power. And there's our final answer. Now, if you recall from the math tips I gave at the beginning of this video, there is a second way that you could solve this same factoring problem. And that is, you can temporarily substitute for the binomial by rewriting it as a single variable. If we look at this quick example here, we see we could rewrite x squared times quantity x minus 7 to the 5th as x squared a to the 5th if we let a substitute in for that x minus 7. Now if we go back to example 5, what that would mean is we would let a equal x minus 3. So feel free to use this substitution if it helps you think a little easier in your factoring. Some students have an easier time looking at an expression like this and factoring it than looking at an expression that has binomials in it. Now in example 6, we have to start off again with finding the greatest common factor. Now between 9 and 27, we can see our coefficient, greatest common factor, will be 9. And we have a negative 9 in the front, so we'll go ahead and pull out a minus 9. Between x to the negative 2 and x to the negative 3, we take the lesser exponent, which would be x to the negative 3. So we're going to factor out x to the negative 3. Then we have x plus 6 to the 5 halves and x plus 6 to the 3 halves. So we'll be able to factor out x plus 6 to the 3 halves. Now to find out what remains on the inside, we know we'll have to do negative 9 x to the negative 2 divided by negative 9 x to the negative 3, which becomes x to the negative 2 minus negative 3, which equals x to the negative 2 plus 3, which is equal to x. Now when we have x plus 6 to the 5 halves divided by x plus 6 to the 3 halves, we know that means we'll have to do 5 halves minus 3 halves, which becomes 2 halves, which is x plus 6 to the first power, and of course we can leave the first power off. Now we have a plus 27 up here, but positive 27 x to the negative 3 over negative 9 x to the negative 3, that's going to become minus 3, and the x terms completely cancel out. We also have quantity x plus 6 to the 3 halves over quantity x plus 6 to the 3 halves, so those will cancel out as well. We're ready to simplify. Negative 9 stays in the numerator. X to the negative 3 becomes x to the positive 3 when we put it in the denominator. The x plus 6 to the 3 halves stays in the numerator. And then we distribute out. X times x is x squared. X times 6 is plus 6x. And then we have a minus 3. And we're already done. We can also use that technique where we substitute for the binomial and let a equal x plus 6 to simplify our factoring temporarily. Now, in example 7, for the first time we're going to have coefficients that are fractions. And if we go back for a minute to the math tips screen I had up at the beginning, my strong suggestion to you when you are working with fractional coefficients is that you get the coefficient's common denominator first, rewrite the expression over that denominator, and then go ahead and factor the variables, because now they'll have integer coefficients, and it's just easier to factor them that way. So in example 7 here, we see we have 4/3 and we have 6. So pretty obvious that our common denominator is going to be 3. So the first order of business will be to write the entire expression over 3. So this first term will be 4x to the negative 7th. Then we have a minus sign. And 6, if it has a denominator of 3, we know 6 is the same thing as 18 over 3. So this becomes 18 x to the negative 3. Now we're ready to factor, because we can see now both variables have integers for coefficients, and it's a lot easier to factor that way. We need the greatest common factor, so we have a 4 and an 18 as coefficients. We know the greatest common factor between them is a 2. X to the negative 7th and x to the negative 3, we know that negative 7 is the smaller exponent, so we'll be taking out an x to the negative 7th. And we have 3 in the denominator. Now, when we get ready to write what's left inside, we know we have to do 4x to the negative 7th over 2x to the negative 7th. So the x to the negative 7s will cancel. 4 over 2 is 2. Now, when we do 18x to the negative 3 divided by 2x to the negative 7, we know we're going to end up with 9, and then the x will become x to the negative 3 minus negative 7, which of course is negative 3 plus 7, so we get x to the 4th. Now the only thing left to do is to take the x to the negative 7th and move it to the denominator. So when we simplify our final answer here, the 2 stays in the numerator, the quantity 2 minus 9x to the 4th stays in the numerator, the 3 stays in the denominator, and the x to the negative 7th moves to the denominator and becomes x to the positive 7. And there's our final answer. In example 8, we see once again that we have fractional coefficients, so we'll want to get our common denominator between 2 and 5. Easy enough to find that denominator. We know it's going to be 10. And in this first fraction, we're missing the 5 part of the 10. So you can think of it as multiplying by 5 over 5. So this will become negative 5 x to the 4th, x minus 5 to the negative 3 halves. Then we have this minus sign. Now this fraction is missing the 2 out of the 10. So if we multiply by 2 over 2, we can see this 3 will become a 6. And then we have x squared, x minus 5 to the negative 1/2. Now the next order of business is to find the greatest common factor. We know that 5 and 6 don't have any common factors, so we aren't going to get anything from the coefficients. We know that x to the 4th and x squared have a common factor of x squared, and since both these terms are negative, let's go ahead and factor out a negative x squared. We have x minus 5 to the negative 3 halves and x minus 5 to the negative 1/2. We know the smaller exponent is negative 3 halves, so that's what we'll factor out, x minus 5 to the negative 3 halves. And to see what we'll have left inside, we have to do the division. Well, we've got a negative 5 x to the 4th divided by a negative x squared. That's going to be positive 5x squared. Now the x minus 5 to the negative 3 halves will cancel with the x minus 5 to the negative 3 halves, so we don't get anything more from that first term. Now there's a minus sign here, but remember we factored out a negative here. So when we have negative 6x squared divided by negative x squared, we're going to end up with a positive 6. Now we have x minus 5 to the negative 1/2 divided by x minus 5 to the negative 3 halves. And we know we'll be taking in the exponents negative 1/2 minus a negative 3 halves, which turns into negative 1/2 plus 3 halves, which is 2 halves, which equals 1. So we're left with x minus 5 to the first power, and we know we don't have to write the exponent when it's a 1. Now in the denominator, we still have a 10, and now we're ready to simplify. The negative x squared stays in the numerator. The x minus 5 to the negative 3 halves, we make the exponent positive by moving it to the denominator. And inside the brackets here, we have 5x squared plus, we'll have to distribute the 6 times x to get 6x, and the 6 times a minus 5 to get minus 30. Now we also, in the denominator, have that 10 there, and there's our final answer. And once again, we can do that temporary substitution where we let a equal x minus 5 to simplify our factoring. We find we get the same answer as before. Now for some extra practice, you can try these 4 problems on your own and then check your answers with those given here below. And here's one last look at my tips for working with these kinds of expressions. I sure hope this video has helped you with your factoring involving negative exponents and fractional exponents, as well as binomial bases and fractional coefficients. So good luck in all your future math endeavors.